Hope everyone able to hear me, right?
Yes, sir.
Okay. So I have one variable, I declared it with 0 and I incremented that variable. Below that I have placed a condition saying if my variable is equal to 1, I say my validation is passed. This out and I say my validation is passed, or else what I'll say is my validation is failed. So this is my validation that I am placing here inside this shared resource. I call this as failed. So what basically happens, the thread 1 which is over here is trying to access the shared resource. In the similar manner, the thread 2 which has done its validation points reached this shared resource. Now my thread 1 is here and my thread 2 has entered this function. Let's take this way. Both the threads are trying to access this shared resource at the same time. I mean, with minimal difference of milliseconds or something, let's consider that. But both of the resources which are, I mean, both of the threads which are accessing this resource are at the same point. So let's put this way. So here is my thread 1, and now here is my thread 2. This is my thread 2. Okay. So thread 1 has executed this initialization, and thread 2 has just arrived to this. Okay. So thread 1 reached here, it incremented the variable, thread 2 initialized the variable, and now what it has done, thread 1 started executing this if condition, and now variable is equal to 1, so the test case got passed. But when it is coming to the thread 2 started incrementing this value. So but for thread 2 the value will be equal to 2, because initially the thread 1 has incremented the value of variable to 1, and now thread 2 is actually trying to do the same step, and now the value of variable will be equal to 2. So but when it comes to the if statement, variable value will be 2, which will not be equal to 1, so it will be failed. The thread 2 execution will be failed because thread 1 has already done some steps, and because of the thread 1 dependency, the thread 2 validations has got failed, which is not desired. And the expectation for thread 2 is not failed, it is passed. So what it actually mean here is like, so for this particular kind of functions or shared resources, when both the threads want to do some validations or some steps, we should not allow both the threads at the same time. So we should allow only one thread to access this particular shared resource at one time. So if that can be done, what happens? So when thread 1 is trying to access the shared resource, initially it will initialize this variable with 0. So here is a variable for us, and this thread 1, when it is accessing the shared resource, it will initialize this variable with 0. And at the same time, when we are allowing only one thread at one time, the thread 1 will complete this function, and now this shared resource will be given to the thread 2. So what thread 2 will basically do after that is it will reinitialize the variable to 0. So thread 2 will not face any problem. So as the variable will be initialized to 0, it will be incremented here, and then it will check this if statement, and then it will throw out a message saying it is passed, right? So we will not face any problem when we are allowing only one thread to access the shared resource at one time. If we are allowing multiple threads to access the shared resource at the same time, we are facing an error. It can be with thread 2 or with thread 1, it depends on the thread scheduler. So if thread 2, if thread 2 is much faster than thread 1, so thread 2 will be passed and thread 1 will be failed. If thread 1 is executing little faster than thread 2, thread 1 will be passed and thread 2 will be failed, as we are allowing both the threads to access the shared resource at the same time. So the whole criteria here is like, whenever there is a shared resource, we should allow only one thread to access that particular shared resource, and we should not allow the other thread to enter into that shared resource until unless the first thread completes its execution. So that is the whole point here. When you're taking the live real-time examples, let's say you have a bus booking portal for you. So you have a bus booking portal for you, and you have multiple seats here. So let's say you have multiple seats and there is only one seat that is left for booking. Now if two users logged into this particular portal, and if both the users are allowed to book this ticket, so if there are two users logged into this particular portal, and if you are allowed both the users to book this particular seat, what happens? You have only one seat, but you are allowing two users to book the seat, and at one point of time, uh, I mean, if both are executing this particular using the shared resource, the final message will be both will be allocated with the seat, because both these particular threads or both the users are using the same function, and so it will be in sequential manner. Both the thread will as the for both the threads, the number of seats count that are empty is equal to 1, because both are going at the same time to execute that particular book seat function. So both will see a empty seat is equal to 1, and both will go into the sysout saying uh, your seat is booked, but which is not the real case. So you should not allow multiple users to act on a single seat at one time. Should allow only one user to use the seat, and later once this user don't want to book his seat, or if he releases the lock, or if he stopped acting on this particular seat, then only you should allow the other user to act on this particular seat, or you should allow this user to book this seat. That is the whole concept of the shared resourcing. So the only one takeaway here is, when you have a shared resource, you should allow only a single user to act on the shared resource. You should not allow multiple threads or multiple users to act on the shared resource. And we need to achieve this in threading, because threading is something that goes parallelly, and it is individual, or it is asynchronous to each other. So each execution flow of thread will be different, but we need to control the execution flow whenever it is accessing the shared resource. And let's see how do we achieve this using threading. So hope everyone understood this, right? So what is shared resource and what has to be done when multiple threads are accessing the shared resource?
Yes, sir.
Okay, so now let's see what happens when multiple threads are using the same resource and what has to be done. So here I'm creating a class, and let me call this as shared resourcing. Let me take the demos at the end once I complete everything, so that if you're running out of time, that would be a problem, because I'd like to complete these topics today. So I'll push the demos to the end. So once I complete everything in the today's session, we'll go for the demos. So I have created a new class. So I'm creating two threads here again. Let's say I'm creating thread 1, implements runnable. You already know how to create a thread. So let me add unimplemented methods here, which is done. Control D. Let me create a new thread to implements runnable. Public void run. Now I'll create a simple static method here. Public static read for int I is equal to 0. I less than 5, I plus plus sits out. Thread dot current thread dot, get name. So don't worry of this thread dot current thread dot get name. We are coming to this properties one just in a moment. So I'm just giving an overview of this. It will thread dot current thread will take the current instance of the thread which is acting on this, and dot get name will give the name of the thread which is acting on this particular statement at that instance. So that is all. So thread dot current thread will give the current instance of the thread which is acting on this particular as a resource or the method, or and dot get name will give the name of that particular thread. And now I am appending the value of I. So I'm now what I'll do, I'm appending the value of I plus I. Now so let's consider this as a shared resource. This particular method I'll call this as shared resource, and I'm asking thread 1 and thread 2 to access this particular shared resource. So this is a shared resource, and I have only one method call that I have there in this particular thread, and that method call is accessing the shared resource. In the similar fashion, I have thread 2 and I have only one method call here, and which is accessing the shared resource. Now both my threads are accessing the same shared resource. So the moment I call this, or I moment I call this or start this thread 1 or thread 2, they'll start executing this shared resource, right? So they'll start keep on what to say printing this statement for 5 minutes. So let me start this method thread 1. I'm creating the instance for that particular class. Control V, T1 is equal to new thread B. Okay, so T1 dot start. What's wrong? Sorry. This is implements, so this is not how we will start this. So remove this thread T1 is equal to new thread new thread 1. Okay, right. So if we are extending something, we can create the instance and we can call the start. As we implemented an interface, we need to call this way. So we need to create a thread class, and to that thread class we need to pass the parameter of this instance. Thread 2 is equal to new thread, and inside this I need to have new thread 2. Okay, so let me call this control C, control V dot start. So just an overview of the code. We have created two threads and we have created a shared resource, and we are asking both the threads to use this or to execute the shared resource at the same time, because we don't have any other functions and we don't have any thread dot sleeps. So we are not asking the threads to wait for anything, and they're not waiting for any inputs or outputs. The only function they're executing is the shared resource right now. So now we are starting both the threads, and let's see what will be the output when we are executing both the threads. So if I'm running it as Java application, so this is something not expected. Okay. Let me do it this way. So if you carefully observe the output, how it is, so both the threads have entered into the shared resource. So thread 0, let's call this as thread 0. The first instance that we created is thread 0. This is thread 0, and the other instance that we have created is thread 1. So these are the names of these two threads. Both the threads enter into the shared resource. So we have two threads. One is thread 0 and the other is thread 1. Both the threads entered into this particular shared resource at the same time. So let's say now thread 0 entered into this particular shared resource and it started executing or it started executing this particular for loop. So thread 0 printed 0. At the same time, thread 1 also entered into the shared resource and it started printing the value 0. And now thread 1 is upper and it printed 1, and then comes thread 0 and then thread 1. The only takeaway here is both the threads started iterating this for loop at the same time. Both the threads are acting on this shared resource at the same time. Now what is our goal is we need to control this threads in such a way that only one thread has to act on this particular shared resource at one time. So we want the thread zeros, all the thread zeros to be executed at one time and all the thread ones to be executed at one time. So initially, if you see, if you are moving this thread 1 dot start to above, I mean if I'm calling this above, so what happened, so this is my function earlier, this is my calls earlier. So if I ran this particular method, what is our output? It is something like this. So this is what that is desired, right? So all the thread zeros executed at same time and all the thread ones executed at the same time. This is happened because we started the thread 1 and then we started initializing the thread 2. It will take some time to do this initialization, right? In the meantime, thread 1 completed its execution. Thread 1 completed using the shared resource. That's why, that is the reason why we have seen thread 0 execution at the same time and thread 1 execution at the same time. But in the real world, we cannot say at what time which thread is coming and started using the shared resource. So this is not the right way of maintaining some weights or something like this. If I maintain some weight between the threads, for sure only one thread will start using the shared resource at one time, because thread 2 will be in the wait state as I have called thread here. So let's say this takes 5 minutes for this shared resource to execute, and if I give 5 minutes over here between, if I maintain 5 minutes of wait between each and every thread, what happens? So each and every thread will like execute or use the shared resource at one time, because we have maintained some waits. But that is not the real case. We should maintain the threads in some other way, or we should maintain this accessing the shared resource at one time, at one time in some other ways, because thread dot sleep is not the right way of execution. Because for example, we know like the execution time for this particular shared resource is 5 minutes. In some other CPUs or in some other missions which is very slow when compared to the mission that you are currently using, so the processor might be slow there. So at that times what will happen, the 5 minutes wait that you are giving or 5 seconds wait that you are giving will not be sufficient, and then again two threads will surely interact with each other at one in those kind of CPUs. So that will be hard coded manner of achieving this using thread.sleep or something. That is hard coded manner of achieving that. But we have some other way that the Java provided us to handle these threadings. So let's see how to achieve that. So I'm keeping back to its original state. I'm initializing here itself. I'm initializing both the threads at the same time, and then I started calling both the threads. So thread 1 dot start and thread 2 dot start. So now let me re-execute it once again to show you the output. So now it is same executed. So it varies, the output varies from time to time. It depends on how fast the threads are. But if you see the case now, the thread 1 take the upper hand, and it executed first, and then comes the thread 0. So if I re-execute again, run as Java application, so it is the same now. Thread 1 take the upper hand. So it varies. Earlier, if you see the first time, the thread 0 executed first, because it all depends on the thread scheduler algorithms. How the thread scheduler is allocating the time to the threads, it all depends on the thread scheduler again. But the output varies from time to time, but the most stable output is this way. So both the threads starts using this particular shared resource at the same time. This is the most stable output. Now our goal is to achieve something that only one thread has to execute this particular method at one time. So to do that, what can be done is we can just call synchronization here. Let me remove. There is a keyword called as synchronized in threading. So if I add that particular keyword here, what basically happens is this synchronized keyword makes sure that only one thread is accessing this particular resource at one time. So you just need to add the synchronized keyword to the particular method. Once it is added, this particular synchronized keyword will make sure that only one thread is accessing the shared resource at one time. So that is the use of the synchronized keyword. And let's see what will be the output once we added this particular synchronized keyword here. So run as Java application. So if you see now, we the thread 0 entered into this particular shared resource, and then it didn't allow the thread 1 to access this particular shared resource again. It locked the thread 1 until the thread 0 got completed, and once the thread 0 got completed, it released the lock to the other thread which wants to use the shared resource. So the same happened here. The thread 0 entered into this particular shared resource, and then this particular JVM logged all the other threads to access the shared resource, as we have added the synchronized keyword here. So once the thread 0 started completed its uses of this particular shared resource and it came out, then the JVM allowed the thread 1 to access this particular shared resource. So that's why we are seeing this. So thread 0 and thread 1 are executing at multiple times, not at the same time. When the synchronized keyword is not added, they have executed simultaneously. Once the synchronized keyword is added, both the threads are running at multiple times, or different instances. So that's all about this synchronized keyword and how to achieve accessing a shared resource each at one time. So if you want me to run this again, and if you're expecting a different output now, so that's not the case here. So maybe the threads that are executing might be varying. So thread 1 take the upper hand now, and it started executing, but thread 0 executed at the last. But each thread, whatever the thread that we are accessing, whatever thread that got the resource, completing its execution, and then only the other thread started using the resource. So if you see this, earlier it is thread 0 which has the upper hand. Now thread 1 has the upper hand, so it completed its execution. Until unless it completes this thread 1 execution, JVM did not allocate the shared resource to the thread 0. So what it all is, thread that got the that got the access to the shared resource may vary, but it will not allow any other resource until unless it completes the execution of the thread which started using the shared resource. So that's all about the synchronized keyword. Let me run it multiple times so that I can show you multiple outputs. So now it is thread 0 which has the upper hand, and it completed its execution, and then thread 1 got its access. So any number of times you run this, only this will happen until unless one thread completes its execution. The JVM will not allow any other threads to access on this particular method or a shared resource. So that is the takeaway, and this is how we will achieve the synchronization or accessing the shared resource in threading. So you can take that example back now. If you want to book one ticket, if you have left with only one seat, so the JVM will not allow the second user to enter into into this booking state until the first user completes his work on this booking page. So he may book or may not book, but if he is there on this booking page, the other user should not be allowed to access the shared resource. Okay, that's the whole takeaway here, and that is how one can achieve synchronization, I mean accessing the shared resource in threading. Hope everyone got this right.
Yes, sir.
Okay, now let's go back and let's see the states of a thread. At what phase, what will be the state of each thread? So let me create a class again. Let me call this as thread states, and let me also create a method control D, and let me create a class thread one linen external, add on implemented methods, control D, simply sys out into thread one in the main class. Thread g1 is equal to thread new thread one. Okay, so I have instantiated this thread one dot start. So now I created a thread and instantiated that, and I'm starting the thread. Before this, let me show you some other things. So if you take this instance dot, you have multiple things here. As I told, we have thread priorities. Based on the thread priorities, it is the task of thread scheduler. It should take the highest priority thread, and it should allocate the processor for the highest priority threads. If you want to get the priority or know the priority of a particular thread, you can use this method get priority. In the similar manner, we have something called as get name, get ID of the thread, and we can also set name, and we will come to all these things: join, notify all shortly. But let's only take the parameters which recognizes the thread. We have something called as set name, set priority, and we also have something called as get ID. Yeah, here is. So let's quickly see everything over here, and then we will move on to that particular topic, I mean to the states of a thread. So this is the thread I have, and let me sys out everything to show you how will be the ID of the thread, name of the thread, and all this stuffs. So t1 dot get id is one thing that I have, and the other thing that I have is get name. So t1 dot get name is the other parameter that I do have, and this out, and t1 dot get priority is the other one. So this says the priority of the thread, and we can also do something like this: d1 dot set name. So if I want to set the name of this particular thread, so I can set the name of the thread, and now if you print out the name of the thread, I mean if you get the name of that, t1 dot get name. So we have set we got the name of this particular thread before, and here it is something that is allocated by the JVM for this particular thread. This name will be allocated by the JVM. Now we have set the name, or we have changed the name to some other name, and now we are trying to get the name of that particular thread. So this name, this print has to be apex thread. Okay, so if you move forward, and we also have something called as t1 dot set priority, and this is priority, maximum priority. Let's keep this as some 7 or something. So if I print this sys out, and t1 dot get priority, so it will have some priority before setting the priority here. So now I'm trying to set the priorities to some other value, and then I'm printing the priority of that again. So if I run this output, so if I run this, let's see what the output will be. Let me clear the console. So if I run this particular method, what basically happens is run as Java application. So I'm running this. So what is the output here? So the first output that we printed is ID of the thread. So this is the ID of the thread. It is 14, and name of the thread, which is thread 0 before changing the name, and priority of the thread, t1 dot get priority, where it is. No, okay. So we started the thread here. That's the reason this is printed into thread 1. So at this point of time, it got the access, I mean the thread is here, so it printed this value, and then comes the priority of the thread. So it is 5 here, so priority of the thread is 5 here, and then we we are setting the name of the thread here, and then we are getting the name of the thread. So now we are trying to set the priority to, oh, why it is not taking it, t1 dot get priority, it didn't got changed. So let me take this thread dot. So the priority of the thread varies from 1 to 10. So the normal priority is 5, minimum priority is 1, and the maximum priority is 10. So the maximum priority that the thread can have is 10. So let me set this priority to maximum, and now let's rerun this and see the output. And let me not start this. Why this is not changing? Hmm. The reason why the thread priority didn't got changed is we are calling the thread at the start, and what happened by the moment we are setting the priority for the thread, it is terminating. So when once the thread got terminated, it doesn't matter whether we are changing the priority for it or not, because thread scheduler doesn't consider that as the thread got already terminated, right? So that is the reason we are not able to set the priority or change the priority. The by default priorities being there with the thread. So to change the priority of a particular thread, it needs to be in the other states other than terminated state. So that's why when we move this start method from the top to the bottom, we can see the priority of the thread got changed from 5 to 10. The maximum priority is something which is called 10. So it is set to 10. The maximum priority is set to 10. So these are some of the properties to recognize a thread. With the ID name, we can also set the priority if you want to execute that particular thread at first when compared to the other threads, or if you want thread scheduler to allocate space for this particular thread immediately, so you can increase the priority. Based on this priority, thread scheduler will pick the thread for the execution. So this is pretty much about recognizing a thread.
Sir, how is the ID given? Like it changes every time you
No,
execute, or is the same? Like
no,
how is it
it is a
given?
constant parameter, and you cannot change that. It is the ID of, you can just get the ID of the thread, that's all. Only name you can change it, and you can also set the priority.
So every thread will have same ID, or how it
No, no,
is
no, it
like?
will be different for each and every thread. So
Okay.
yeah, ID will be different, but for one
So
thread,
how it is given is like nothing we can know
yeah,
about
it's
it.
the internal algorithm of this thread implementation, and the ID will be given by it.
Okay. Okay, sir. Thank you.
So now we are done with this. We know how to set the name, get the name, and setting the priorities and all these stuffs. So let's go forward with the states of the thread. So t1 dot start. So here I'm setting the state of it. T1 dot start. Before this, I'm marking like this. Sys out T1 dot. So we have something called as get state. I forget to mention here. So this get state will return as the state of the thread. Uh, what is the state of the thread at this particular instance of time? So I have said I have done this way, and now again I'll call it here. Let me put some thread dot sleep here. Thread dot sleep of let me give 1000 seconds here, and let me give thread dot sleep of 5 seconds here. So what basically why I'm adding the threads here is, so this thread, this class or this particular thread maximum will be executed in 2 minutes, right? So this is 1 minute that we have added, and let's say it is taking 1 minute for initializing and calling this all the steps. Let's say the maximum it can take is 2 minutes. So I'm waiting here for 5 minutes, so which is much more than the maximum execution time of this particular class. Once, so we can say this particular thread will be terminated for sure within 5 minutes. So I want to show you the terminated state. That's why I added 1 minute here and I added 5 minutes here. Now if I print something, the state of the thread here, if I print the state of the thread, so get state should be terminated here. So let's see the output and then we will come back to the explanation. So I'm running it as Java application here. Terminated. So we covered three states here. One is new, other is runnable, and the other one is terminated. Okay. So the moment we initialized the thread, we haven't started it. So it is in the new state. And once we clicked on the start, it is in runnable state. And it is that once it is in runnable, it is an indication to the thread scheduler that, hey thread scheduler, here I am the thread, I am ready to go for run. Or if you take our example, it is ready to go onto the bridge and it has all the required parameters, or it has achieved all the prerequisites to go onto the bridge. So now this thread is in runnable state. The moment we clicked on start, it is in runnable state. So the moment when the start method is not called, or when we have not started the thread but we just initialized the thread will be in new state. So now we allowed the thread to complete its execution, and then we read the state of the thread, and now at the end the state of the thread is terminated. So these are all the three states. These are three states of a thread. One is new. New is something when we haven't started the execution of the thread, and once we started the execution of the thread using dot start, it is runnable, and we have waited, or we have given enough time for the thread to complete its execution. So then we read the state of the thread, it is terminated. So these are the three states of the thread, and we are left with waiting and time waiting states, blocked awaiting and time waiting states, right? So we need to cover those two now. So hope you understood these three states, right? New, runnable, and terminated.
Yes, sir.
Yes. Hope every others understood this. I want to hear from you. So everyone is clear still here, or do you want me
Yes,
to
sir.
repeat some more things? Everyone is clear, right?
Yes, sir.
Yes.
Okay. So now let's move forward and let's try to get the states of other threads. I mean, get the other thread states. So the other one is waiting on time waiting. Time waiting is nothing but we are forcefully pushing the thread to waiting state, and that waiting state can be achieved by just using thread.sleep. So let's carefully, we need to align here. Mm, state, control shift phone, control C, and control V, control V, control V, control V, and add Java application. Everything is runnable. The whole concept here is, so let me explain you how I'm going to achieve this. I'm just giving a trial and errors here. So this is my thread and it is in runnable state now, and now it will start executing this thread. So here this thread is going into time waiting state, because here we are saying that this thread has to be in sleep for 1 minute. Okay, so it is in wait for 1 minute, and then in this 1 minute this particular thread will be in time waiting state. Okay, so we need to capture the state of the thread when it is here exactly in this particular 1 minute. So that is what we need to do. So here when the thread is, when once the thread execution is at this point, so the thread will be in the time waiting state, and we need to capture the state of the thread exactly when it is here. That is the whole concept here. So let me take this way, let me increase the time. so that we will have ample of time to capture the state. So what I'll do here is I'll wait for some 2 seconds. I'll wait for some 2 seconds, and then within 2 seconds I hope this will be executed and it will call this particular method. So let me get the state of that here. Shift home, control C and control V, control S. Okay, now let us try to execute this again. Yes, terminated. So if you see, time waiting is nothing but it's just the thread is in waiting state and it doesn't want to execute that particular amount of time what is passed as the parameter to that particular thread dot sleep. What we have done, we have started the thread and we thought like to execute or initialize and start to execute this particular into thread 1. Let's assume it is taking 2 seconds, and then after this, after executing this particular statement in this particular method, it will enter into thread dot sleep state. Here it will wait for 5 seconds, so we consider that as 2 seconds, and then we got the state of the thread, and then we assume that it is here in this thread dot sleep state, so we are getting the state of it, so it is time waiting state. And then it completed execution for 5 minutes, and at last the state of the thread is terminated. So it is what the timed waiting state means, or time waiting. Let's to keep it simple. So this is time waiting state. Whenever the thread is waiting, I mean for specific amount of time, we call that as timed waiting state. And then if we move forward to the leftover state, which is waiting. So blocked awaiting is something the thread is waiting for the resource. I mean to say, if it is depending on some other shared resource, or it can be any kind of resource, but the thread should wait for something to happen. Then only it should. Then only it can start executing further. To keep an example of it, to put an example of this, it's what can we take it as an example? So waiting is something, it's interdependency again. Let's say let's take this example only. I mean to say, the thread 1 started using this particular function, right? So this shared resource, and we synchronized this particular function. So the thread 2 cannot access the shared resource until unless thread 1 releases this particular function, or until unless thread 1 releases the lock on this function, right? So until unless thread 1 releases lock on this function, thread 2 cannot use this particular resource, right? So at that point of time, thread 2 has to be in waiting state, right? So that is called as waiting state or blocked state, because this thread 2 is blocked to access the shared resource, or it should be in waiting state to access this resource, as thread 1 started using this particular shared resource and it hasn't released the lock. So once thread 1 releases the lock, then only thread 2 will be able to access this resource. Until unless thread 1 releases the lock on this particular shared resource, thread 2 should be in waiting state, and it should wait for the thread 1 to release the lock on this particular shared resource. So that is called as waiting or blocked state. Thread 2 is blocked by thread 1, as thread 1 has kept some lock on this particular shared resource. So once the lock is released, thread 2 will be able to access that particular shared resource. So this in that particular at that particular point of time, thread 2 will be in the blocked or waiting state. So let's try to implement that. For that I need to create another thread, class thread. Let me remove all other things here, so we understood the other 4 states. Let's look at only on the rest over state, which is left, which is that is waiting. So it is runnable. and I'm opening and closing the thread, and let me implement unimplemented methods. Let me delete this. Let me put a sleep of 1 second here. This is out into thread 2 and thread dot sleep. Let me wait for 5 seconds here, and at the end let me put a sysout statement saying thread 2 execute completed. Thread 2 execution completed, and here I'm waiting for 1 second in thread 1, and sys out thread 1 execution started as thread 2 execution completed. Okay, we have two threads like this. In the thread 1 we are printing something at the start, and then we are waiting for 1 second, and we need to add something here. Let me tell you later. So we also have a second thread, and in the second thread we have one sysout saying I'm into thread 2, and I have some wait here which is 5 minutes, and then I'm saying thread 2 execution got completed. Now in the thread 1, let me create the instance of this particular thread. Control C, Control V. Let's not do this. Extends thread, so that we can directly create the instance of this. For now I'm doing it. Is equal to new thread 2. Okay, so on this particular thread I'm calling a method called as join. So what is this join mean? Let me surround this with try catch. Control S. Now let's understood what is join mean here. Let me do this. Let me complete this piece of code as well. T2 is equal to this, C, and Control V. T1 dot start, T2 dot start. So this is the whole code that can accomplish the things that we want to see here. So we have created two threads. One is thread 1 and the other one is here is the thread 2, and this is the thread 2, and we also created the instances for both the threads, and we started the threads. So inside thread 1 what we have done, we as I told, we have one sysout, we have some sleep, and then we have some code. This is what we need to understand. Sorry, this is what we need to understand. And at the end we have something, a sysout statement saying thread 1 execution started as thread 2 execution got completed. So you need to understand something here. So these statements will make sure that uh, the rest of the statements should not be executed until this particular thread got executed, completes its execution. So what is our thread 2? Thread 2 is something this, we printed something, and we are waiting for 5 seconds, and then we are printing some statement. So thread 2 dot join, we have created instance for this, and thread 2 dot join. So thread 2 dot join will make sure that thread 1's execution should be on hold until the execution of this. Oh my God. Okay, so this will make sure that the thread 1 has to be on hold until the thread 2 execution got completed. This is what join means. So on whichever thread we are calling this join, that particular thread execution has to be completed for the calling thread to go to the next set of statements to be executed in this particular thread. So until this statement will make sure that until this particular thread completes its execution, whatever the steps it can be, it can have. Here we have two print statements and we wait for 5 seconds. So unless all the steps got executed, it will not move forward to the next steps execution. That is what all it means here is. So as here we are waiting for another thread to complete its execution. When we capture the state of the thread here, exactly here, what it will be in a waiting state, because the thread 1 is waiting for the thread 2 to complete this set of statements which are over there here, right? So that is what all it means here. So we can achieve that with join. So I'm repeating, join is something which will make sure that the current thread in which it is called has to be on hold state or the blocked state until the execution of the steps that are there in the calling thread, or the call, sorry, it is called thread, uh, on which we call this join has to complete its execution, its complete execution, for the calling thread to proceed to the next steps of execution. So this is the calling thread and this is a call thread. So we are calling the join on the call thread, and this call thread has to complete its execution so that the calling thread can resume its execution further. So until unless at this step, it will keep on waiting for the thread 2 or the calling thread, called thread to complete its executions, so that once it is completed, then only it will proceed executing the rest of the statements that are there in the calling thread. So that is what join means. Hope you understood what is join clearly. So if not, it is very important to understood. So if everyone understood this, I'll move forward, or else I'll try to explain this again in some other way. Uh, did everyone understood
So
this?
can you show it above? Can you go up?
Okay. So this is thread initialization. You doesn't need to bother about these statements. Let's leave this. This is just start. We are calling the threads that we have instantiated, and in both the threads we have few things. In thread 1 we have some steps, and thread 2 we have some steps. Here with the join we created interdependency between the threads. So this join makes sure that this thread or the calling thread has to be on hold until unless this instance on which we are calling the join completes its execution. So it will not complete its so until unless this statement is printed, thread 2 execution card completed is printed, it should not print this one, because this join has to make sure that the execution of the thread 2 is completed, then only it will come to this particular statement, or else it can resume the execution of this particular calling thread. That is what all it means is. So to keep it simple, join is something which will make sure that the call thread has to complete its execution for the further steps to proceed. So our expected output is this statement has to come before this statement at all the times, because we called join on thread 2, so it needs to complete its execution. Once this execution of this thread 2 is completed, then only it will start resuming the execution of the thread 1. So resuming in the sense, it needs to start executing the thread 1 from here. So that's the reason this statement has to be printed in the console before this statement. Okay.
Okay, sir.
Yeah.
Yes, got it.
So let's see the output now. Let me start the execution of this. Run as Java application.
We are getting output in other things.
Yeah, we are getting a wrong one. Like,
Yes, we are getting a wrong one. Let's sort out the error where it is. So we are starting both the threads here. So thread 1 is coming. It is into it. Right. So let me tell you the reason. Here in the main method, what we have done, we started both the threads, right? So thread 1 started its execution and thread 2 also started its execution simultaneously. Hope you got the error by now. So now we got the right output, right? This is the right output. Agreed?
yes, yes.
So now we got the right output, but let me tell you what is the error before. So what we have done in the before case, we started both the threads at the same time, right? So let me take a new screen, or that is fine if you get the errors, but we should be able to resolve them. That's the only point. So what we have done earlier in the main method, we called two threads. This is thread 1 and this is thread 2. This started its execution. Thread 1 started its execution and thread 2 started its execution. So in thread 1, what is the first statement? So both of them started execution. Okay, so that we are aware of. Both the threads started its execution, and in the first thread, what is the output? So it started executing the first thread. Inside this thread, it printed into thread 1. In the same time, it also started executing the thread 2 into thread 2, and 5 milliseconds something. It's a different output. Now what we have done, we waited for 1000 seconds and we created instance and we are waiting for the join. We haven't started this thread, and this thread instance, it doesn't know, like we haven't started. This thread will only look for this instance of the thread which is there inside it, because this is individual thread that we have created, and it will keep on executing this particular statement. So let's say, what is this thread 2 is individual. It waited for 2 seconds and it will print this thread 2 execution completed. That is individual thread. And coming to this particular thread, so as we haven't started this thread, inside this what will happen, the join says that there is no thread that is running inside this. Okay, join will check whatever the thread that is associated with this thread, or which is called within this particular thread. Okay, it's a sub process in it. So if you want me to keep it short, the thread which we are calling inside this is a sub process in this. So this is a sub process in this, and this thread is called inside the main thread. So it will wait for this process to complete for the other for the rest of the process to proceed. So but here what we have done, we haven't started the process inside this main process, or the main thread. We are just saying, we are just created instance of it, and we are checking whether to join on it, or to wait for the other thread to complete its execution, which is not yet started. It is an individual thread and there is no relation between this thread to this thread. uh, uh, you got this right? So we have created the instance over here for the thread, and we started the thread here, and it's a separate execution which is nowhere related to the thread 1. Got it, or do you want me to repeat this again?
Yes, sir.
So
So it
that
is
is
just,
what like first time it's executed all its steps and then it's executed thread 2, right? Because we didn't initiate thread 2 start. We didn't start thread 2. That's why it's executed first thread2 dot join, then after that it's executed thread2, right?
Sorry, your voice is breaking for me. Can you please repeat your question, please?
So, so first time, like we didn't started thread2 and just we did a thread2 dot join. So thread2 dot join executed their statement, and after that it's executed thread2, right?
Right. So there is no interdependency created earlier. So we are just calling, we created two threads and we are just called here in the main method. We separately launched the thread 2. So there is no interdependency, and for what the thread, so there is a instance created here and this is a different instance. So it is not the instance that is related to here. So let me also paste the earlier code that we have. So this is something, and it is clear that this instance is different and this instance is different, right? Is that right?
Yes, sir.
So this instance is different and this instance is different. So we are calling the start on this instance and we created this instance, that's all. We haven't called the start on it, but we are checking for the join on it. So when we haven't started it, the join for sure says that this is completed, right? There is nothing that is running on this instance until unless we started on this, unless, yes, Hemali, I'll shortly come on to that point. What is the difference between time waiting and waiting? So for now, let's try to understand this. So you see this T2 is another instance to this instance that we have created here. On this instance, we created a start, and this is a separate instance that is running in our process. But this instance, earlier we commented this, we don't have this statement. So if you are saying on this instance, if you are checking if something is running on it, it will say there is nothing running on it, right? Until unless we start this thread, there will be no operation running on this particular instance. Is that right?
Yes, sir.
Yeah. Let me explain this. So here we are creating an instance for thread 2. This instance is different. Even if we call on t2 dot start, and if you're calling t2 dot join, there is no relation. The names might be same, but the instances are different. This is pointing to some other location and this is pointing to some other location, because this is a new object that we have created in the heap location, and this is a new object that is created in the heap location. Every time we call a new keyword, an object will be created in our heap memory, and that object reference will be stored in the reference variable. So the reference variable names are same here, that's all, but the instances to which they are pointing are different. That's the reason that t2 which is declared over here nowhere points to this instance, and it will nowhere take the execution of the thread 2 which is started here. So as this is not started here, join will says on this, we are saying instance on this. So if you are saying join, if you are calling join on this instance, it will say that there is nothing happening on this thread, as we haven't called this thread dot start on this instance, but we called thread dot start on this instance, which is a different scenario. It is an individual execution on the processor. There is no relation with the thread 1. But here we have created a thread 2 instance which is different, and we are checking join on that. As it said there is nothing happening on the thread 2 dot join, it printed this statement, and later this thread 2 execution printed the rest of the statement which is there here. Got this? I don't know. Are you clear this, or do you want me to put it in another way?
I understood,
Little
sir.
confusing actually. Yeah.
Confusing, right? So let me put it diagrammatically so
Yeah.
that you'll understand this. So let me clear this. But you need to clear with this, you need to be clear with this. So what the only, for now you just understood only one point. So what is the instance that is created here? It is the instance of this particular class thread22, right? So this is one instance that is created for this particular class. Am I right?
Yes, correct.
So this is another instance that is created for that particular thread, right?
Yes.
So we have one class here. We have one class here. So let me put it this way. So we have one class here, and we span two instances of this particular class. We created two instances of this class. Okay. So this is one instance of the class that is created, and this is another instance of the class that is created. So the reference variable of this particular instance will refer to this particular state, right? So let me put this as this. Let me put it as reference 1. So this is reference 1, which is in the main thread, and this is reference 2. This is reference 2, right? So this is reference 1 and this is reference 2. Am I correct? So every time I call new class name, every time I call new class name, a new object will be created in the heap memory. So new class name will create a new object in the heap memory. In the similar fashion, if I call new class name, it will be different, right? So a new object will be created. So the n number of times you call this statement, n number of objects will be created in the heap. Am I correct?
Yes.
Yes, sir.
So let's carefully observe this code here. So I have created instance for this object, or instance of this class. I called start on it. So I'm calling start on the first instance. I'm calling start on the first instance. Here I'm calling the start. For this instance, which is in the main class, I'm calling the start method. So let me draw something like this, and let me put start here, and this thread is started and it started its execution. So but if you see this particular thread, if you see this particular reference variable, no start is called here, right? Only instance is created. There is no operation, or the process is not allocated this for this particular thread. Am I clear? So
Yes,
let me
correct.
also name this. This is in main method. This is in main method, and this is in class 2 class 1, right? So this reference is being done in class. What is the name of it? Class 1 2, right? Class 1 2. This instance is created in this particular class, and this instance is created in this main method, which is there in this what is the class name? This is in thread states. It is in thread states class of main method of. So this class is thread states. So this instance is there in main method of thread states class, right? And this instance of this particular class 2 2 is there in class 1 2. We call start on the instance that is created in the main method, but not in the instance that is created in class 1 2, right?
Yes, sir.
Yes.
So what will be the state of this? This is in runnable state. As start is called, it will be in runnable state, whereas this thread will be in new state, because we just created the instance but we haven't called the start method on this particular, which is there in this particular class, right? Right, got this until here or not?
Yes, sir.
Yes.
Yes, sir.
Yeah. So this instance is different. What I all mean to say is this instance is different and this instance is different. We called start on this. So processor allocates some space for this thread to execute, and which is a different instance. And this thread, which is a different instance in thread 1 2, is in new state. It is not executed yet, or it is not started yet, right? So what happens? We have another instance that is created, which is thread 1. So this is thread 1 and it is started. This thread 1 is also started. this is started in the main class. So this is started.
Mohan, can I tell you something?
Yes.
Like you can give the join in the main method so that it will be more clear than the confusion, because the thing here is the visibility is not there, so they are not. So we are not able to see which thread. So if you give the start in the main join in the main, it will be more clear, I think.
Here you want me to give
I was
T2 to?
about to ask this if we can give it in the main method. I was about to ask this.
No.
Yeah, like you
What?
can give after 2 dot start, you can say like T2 dot join.
So if you consider this, if you want me to give it here, what happens? This main thread will wait for the T2 to join to complete. This thread one will not wait. Got this right? So if I give T2 dot join here, so main thread will be on hold until T2 join will complete, and then it will start this particular steps which are there after. It's not T1 that will wait,
Okay.
because
Oh,
this
okay.
is the main thread.
Main is a thread. Okay.
Yes,
Okay.
main will be
Got
a
it. Got
thread.
it. Yeah. Yeah.
Okay,
Mm-hmm.
that's the reason I
If it's
have
a separate method, then you can just try it there. Okay.
so this is another thread that's started, and we also started this thread. It will be little confusing, but the moment you understood this, it will be very useful for you, and it will be clear for
Sir,
you.
it is confusing because the name, both of the name are similar. If you give the
Yes.
different name in
No.
thread 1,
It's
2, then it will be fine for.
yeah, it will be easy for understood, but we cannot discuss all these topics. So once we get the output, it's over there. We will not discuss all these topics, and you will not. We will not. We might not have come here. So we need to understand this instances. That's right, right? If I give different name here, and if I got the right output, I might not have explained all these topics, which are very important in my sense. These are very important. So
Yeah.
it's very helpful for us. Maybe we may not be clear now, but once we clear, all these topics will be very helpful for us. So that it's as simple as that. If I give some name here, and if I get the output, we might not have discussed all these points which are over there here. But as we have given the same names, and we encountered some issue, and then comes the explanation, and let it take time. If you didn't understood this, I'm okay to explain a number of times, but the whole intention here is like you try to understand, and you put your efforts over here, because this is very important, and you should know why the thread is not waiting, or this is not printing before giving the output in the right way. So I'm splitting this into steps. Now the first step is you need to understand this instance is different to this instance, and in on this instance we call the start method, because so that it is in runnable state. On this instance we haven't called anything, so this is a new state. So until this you are clear, right? Let's speak about the rest later.
Yes, sir.
So everyone understood this, right, until here?
Yeah. Yeah, we understood.
Okay, that's great. So let's move forward and put this way. So in the main method we also started thread 1, right? In the main method we started thread 1, right? Thread 1 in the sense this is the one. So we started this thread, and we started this thread, right? Am I right?
Yes,
Yes.
sir.
Yes.
So this is one thread that we have started, and this is the other instance that we have started. These two are the ones that we started in the main method, right? So let's go step by step. What we have done initially, we have created instance for both the threads, and we have called start on both the threads. So these are the two things that we have started now. So these are the two things that we have started now, and the execution started for on both the threads simultaneously. So on the thread 1, it printed into thread 1. So as thread 1's execution got started, it printed into thread 1, into thread 1. In the similar manner, it also started the thread 2. So on the thread 2, the output is into thread 2. Here the output is into thread 2. Okay. So these are the two outputs that we are getting. And then if you come here to the next step over here, thread 2 t2 to thread 2. This instance is, what is that instance? This is that instance, right? This is that instance which is there in the this particular class. Oh, shit. Join line here itself, that's better. Am I right? This instance is related to, is there in this particular method, correct?
Yes.
So what is the next step that is being executed? So we created instance in this particular method and we haven't called the start on it, so it will be in the new state, and then we are calling the join on this particular instance. So we are calling join on this particular instance. So what happened? There is no action that is being performed on this particular instance of this class. So there is no execution complete is started on this. So thread dot join will say that, hey thread 1, there is no execution that is being going in on thread 2. So you can continue with this with your execution. That is what the response that will be given by the join on this particular thread. As this is in the new state, there is nothing that is happening on this thread. So thread 2 dot join will give a response to this thread 1 saying, hey thread 1, there is nothing that is happening on my on this instance, so join. So I am the join and I am saying that on thread 2 there is nothing joining because the user didn't call anything on this, he just created, and the thread is in the new state. So you can proceed with your execution. That is what the response that thread 2 gives to this that particular thread 1. Is this clear?
Yes, Mohan.
Right. So that is the response that thread 1 will get from this particular instance. So it will proceed to this to the further execution as the response is clear from the thread 1. So it will print this execution. So it printed this it printed this output before here. So let's come back here, and this will be the output that will be printed here. Okay, so this will print it. This is the first output that we see in the console, and this is the second output that we see in the console. This is the second output that see in the console, and this is the third output because this thread 2 gave the clearance. This instance gave the clearance for this particular thread to go ahead with the execution. So it executed this, the last statement. Here we have 5 seconds of wait. Within this 5 seconds, we can complete all the execution of all these steps, because maximum we have 1 second wait and the rest are all executions. I mean, rest are all simple steps. So as we have waited for 5 seconds here, this is the last step that will be output that will be printed to the console. So the last statement that will be printed is this particular statement, thread 2 execution completed. Control C, and if you come back here and say for this one, thread 2 execution completed. That's the reason when we haven't called the start on this, when we haven't called start over here, uh, the output will be this sequence. So first output will be thread into thread 1, and the second output will be into thread 2. Thread 1 execution started as thread 2 execution completed, because thread 2 gave the clearance to thread 1 that there is nothing running on this, because user haven't started the execution of the thread, he just created the instance of the thread. It is in new state and it is not in runnable state, so you can go ahead with your execution. That is what join says to the thread 1. That's the reason this will be printed. As we have some wait for 5 seconds here, this will be the last statement on the thread 2 which is started here. Is this clear now? So the moment we started, we added the statement t2 dot start here. What happened? What will happen? Like, this thread 2 instance will not given the clearance for this thread 1 until unless it completes all the thread 2 statements. As it is not started, it gave the clearance for the thread 1 to go ahead with the execution. But once we clicked on start, once we started the execution on this thread, it will not give the clearance until unless it completes all the execution of the steps of this particular class, right? It will not give clearance until it's completed all the execution of these threads, right? If we call the start here, so it means that we have started the execution, or we moved this thread into runnable state, so that join will not give clearance to this thread, saying join will not give clearance and it will wait until all the steps in this particular class got executed. Once everything got executed, thread 2 will give an clearance to this thread 1, saying, hey thread 1, now the thread 2 got completed execution on this instance, so that you can proceed with the execution of rest of your steps. Got this?
Yes, got it.
Is everyone clear?
Yes.
Yes, sir.
Yes, ma'am.
Yes, sir.
You got this, right? Right, thanks. So let's move forward to some other topic.
So, Mohan, one question here.
Yes.
So, what happen if we remove this t2.join and instead of we can put t2.start in the try?
Here you want me to remove this, right?
Just put the comment and put that t2.start in that place. Yeah.
So it will there will be no dependency. So it will start this thread separately, and this will be executed before the expected output. It's like an how the
But
output
in the
is.
middle of but in the middle of thread one, we're starting the new thread, right?
Yes. That will be a separate instance on the processor. It will follow all the threads life cycle. So let me run this for you. So you'll see the same output what we have discussed earlier. So it started, we started the thread 1 on the top, so we are into thread 1 and we started a thread 2, it's a different instance. So then it printed this particular statement. So as we started this thread in a separate instance, it started executing this run method. So it printed this, it waited for 5 seconds and then it printed this. That's a different threads execution.
There is no dependency.
Yes,
That
there
is
is no
why.
dependency.
Okay. All right. Thank you.
Okay, right. So the other important topic that I'd like to explain here is producer consumer relations. So the next important topic and the last topic in threads is this one. So let's say I have an e-commerce application. In that I have a producer or the seller, and I have a person called as consumer. So this producer will try to do some actions on the product that is being added to this e-commerce application, and the consumer will also act on the same thread, right? So this is the product, this is his product that is available here. So this e-commerce application owner will give a constraint that the maximum number of products that I can sell on this website is X. Let's say it as X. So let's say the maximum amount of the maximum quantity of the products of a particular product that he can sell on this particular e-commerce application is X. Let's say X. say the maximum quantity or the maximum number of products this producer can add to this e-commerce application is X. He cannot exceed or he cannot add more number of products other than the X. Okay, so this guy will have many criterias based on the capability or the server capabilities, and he may have many number of considerations. So if the number of product that he's selling on this application exceeds that amount of count, maybe his servers might get crashed. For example, a new phone is launched, and there will be a limitation on the quantity number of quantity or the amount of phones that this e-commerce application can sell will be limited, because if it is exceeded and and more number of users or more number of users came into picture or trying to access the same server, it may get crashed, and he may have some technical issues. So that is the reason he has put some constraint on the producer that I can sell only these many number of phones on my e-commerce application. So what is the condition here? So the producer should not be able to add quantities more than this, or should not add any number of quantities more than X. The maximum number of quantities that he can add on this onto this e-commerce application is X. So this consumer should not be able to buy if there are no products on this particular on this application, on this e-commerce application. If the product count is 0 or the product is out of stock, this consumer should not be able to buy the products from this e-commerce application. So that is all the condition here is. So this person should not be able to buy the products if the count is 0, and this producer should not be able to add the quantities if the uh, let's say if it is equal to the maximum number of quantities that the e-commerce application has allowed this particular producer to add on this e-commerce site. So these are the two conditions. So if let's say we are checking for a phone and it is out of stock, what we will do, we will again check after 2 hours, 3 hours, 2 days, 3 days, or a week or 2 weeks. So we keep on checking whether the product is up and it's they are selling the product or not. The consumer will keep on checking for that. So instead of checking on it for multiple times, if there is an option for the producer, he's the producer he's the producer. So if this producer or this e-commerce application provided us a feature saying when the producer added some products to this e-commerce application, the e-commerce application has to notify to all the users who is looking out for this product. Did you got this? So this e-commerce application has a feature saying that uh, whenever the moment the producer added some products to this particular e-commerce application, this e-commerce application has to notify to the users that the products are available on this particular website for you to buy. So if you see our popular websites like Amazon or something, you'll see a notify button when there is when the products are out of stock, and you just need to give your email ID and you just need to click on notify. So once the product is available, a notification mail will be sent to those email IDs. The concept is same here. So consumer who wants to buy some products on this e-commerce application is waiting for the products to be available. So instead of this consumer keep on checking for the products on the application, it will be very simplified and nice feature if the e-commerce application notifies the consumers when the products are being added by the producer. Got this?
Yes, sir.
So now let's try to implement this. How can we achieve using threading? So there can be n number of threads who are looking for this product to be available, and there is one producer. So once the producer added the products, all the users should be notified saying this product is available and you can buy it over here. So the same keyword applies here. We have few keywords in synchronization of thread. One is wait, and the other one is notify, and the other keyword is notify all. So now you can correlate these words with here. So what did the consumer has to do? He has to wait until he receives a notification from the e-commerce application saying saying the products are available. Still then the consumer has to be in wait state. Okay, so this notify is something what the producer will do. So once the producer added some products to this e-commerce application, this e-commerce application has to notify this to the consumer saying the products are available. So this consumer is in wait state until this notification is given by the e-commerce application to this consumer. So that is what notify means. Notify all means there can be n number of threads that wants to act on this particular shared resource. You can also consider this a shared resource or a product. So there can be n number of consumers who wants to access this product or who wants to buy this product. So notify all will notify to all the users who are trying to access this shared resource. That is what notify all means. These are the three keywords which plays a major role in this kind of scenarios where there is an interdependency on the producer and the consumer, or resource 1 to the resource 2. So in this way we can reduce the effort of the consumer or the producer. So we can because the consumer doesn't need to keep on checking for the product by going to the application. Instead he will be notified the moment the product is available on the e-commerce application. So that is what notify means, that is what wait means, that is what wait state is. Notify and notify all means. This is what theoretical concept when coming to the synchronization. Let's put this in practical things. Hope everyone got this before proceeding further.
Sir, there's also yield. Is it in these days or?
Yield is not related to this one. Yield is something different concept. Yield, let me put you this. Yield is something when once a thread has called yield on it, it says that the thread the current thread I'm not so important for the execution for the current run or something. So when once the yield is called, the thread itself declares that I am not a priority one. So if there is some other priority that is coming, you can allocate the, it says to the thread scheduler that you can allocate the processor to that particular thread. That is what yield means. It is not related to this particular concept. So hope you understood the yield
Okay.
as well.
Yes.
So let's say I have two threads, thread 1 and thread 2, and if the thread 1 called yield on it, it says that it means that it itself declared that I am not a priority thread. My execution is not priority and I am free to give the space to any other process or any thread that is coming on its way to execute. So once any thread that is coming on its way which is priority for its execution, then thread 1 which is called yield on itself says to the thread scheduler that, hey thread scheduler, I am not a priority thread. It's my self declaration that I am not the priority one. So if some other thread is coming with high priority, you can allocate the process to that particular thread instead of mine. So once that process or once the execution of that priority thread is completed, you can give back the process to me. So till then I can be on wait state. That is what yield means. Yield is something, it is self declaration by the thread saying that I am not the priority thread, and it's an intimation to the thread scheduler that you can give the process to some other threads. That is
Okay,
what
sir.
yield
Thank you.
means. So wait, notify, and notify all. Let's discuss this in practical. Give me a minute. So let's implement this particular thing. So let me create a class again. I'm creating a new class. Let me name this as producer consumer, and let's add a main method here. Let's click finish. So here let's add a class producer class. So inside this, let me create a linked list, and the parameters should be string, and let me say it as product list is equal to new link.
Sir, wait. Hello,
Yes,
sir.
hello.
So wait, notify, and notify all. These are all. What are the states called as?
Notify all. This is achieve the intercommunication.
So these are thread states, or what? What do they
No,
call it
these are
as?
not the thread states. These will establish the intercommunication between the threads. I mean to say, so let's say this is producer
Okay.
thread is one thread and the consumer thread is one thread, right? So the producer thread is saying to the consumer thread that I have added some products.
Okay.
Okay.
Okay, sir. Thank you.
So let me add, I have some product list that I have, and the capacity that I can add to this is capacity of the product is, let's say it as 2. So that is a maximum capacity a user can add, or the product list, a number of products that can be added. And now I can say a method called as produce. Inside this method I have some steps. Each value is equal to 0, and while for while product list dot size is equal to capacity. I need to wait. I need to wait. I need to put some output statement. Producer produced value, that is the value here. So I'll shortly explain this code for you. Let me put the code here and then we'll come back to this. So let me add this value to the product list. Control V dot add. That's the thing of into. Let's add value plus this. So this is being done. And let's add a small wait here. Dot sleep, and let's add 1000 milliseconds. So this should not be string, this should be teaser. Now let me create another method, public void consume. And this is my method. So by now you should understand this particular method. So here what we are saying, we are creating a method, and this producer has to be on wait state if the maximum size of the product list reached the capacity. So once it is equal to capacity, he cannot add any more number of products to this particular list or to the product list. So he will go into wait state. If this condition is not met, he can add the products. I'm just incrementing a dummy value for showing the products. So once he added the product, he needs to notify to the other threads who wants to access that shared resource, right? He has to notify to the other threads who wants to access this resource. So other threads in this case is consume thread. So consumer wants to access this thread, so the consumer should be able will get the notification saying that producer has added the products. So now it's the term of consumer code. So as a consumer, he, again we need to add. So why we are adding an infinite loop here is like while true is an infinite loop, because this thread has to continue until unless we stop this. So producer should always able to add the products to the e-commerce application, and the consumer should always be able to access the buy the products from the e-commerce application. There should not be any restriction on the selling or buying. So that's why we are creating an infinite loops here, to make sure that it's an infinite process. There should not be any stoppage or the blockage for the producer or the consumer until unless the maximum capacity is reached, or from the consumer side the product list is zero. Then only he has to be in wait state, but the process should not be closed. Okay, so what is the case for this guy? For the consumer, if the product list is zero, if the product list is equal to, let's say, if it is zero, if the size of this product list is zero, he should be in wait state because he don't have any products on the application to buy. So product list dot size is equal to zero, then the consumer has to go for wait, has to go for wait, has to wait, and then value is equal to product list dot remove first. So remove first, it will remove the first element, and then I am saying sys out consumer consumed, and the value is something like this value. So once he consumed it, thread dot sleep dot sleep. So here we need to give some, let's give some weight here. Let's give some weight here, and we need to notify once this process is done. We need to give the notify, and this method has to be synchronized only because it's a shared resource. Only one thread has to access this at one time. So I'm giving synchronized here, and this also has to be synchronized. We are done. We are done with the producer and the consumer, and we also understood this, right? So producer, the condition is if the size of the product list on the e-commerce application reaches the maximum capacity, he has to wait. He should not be able to any more number of products. So if it is not met, if he is not in wait state, he should be able to add the products, and he can also give the notification to the consumer saying the products are there on the application, so that the consumer threads can get that lock and can consume the products which are there in the application. So the consumer has to go to wait if the product size is zero on the e-commerce application. So once he consumed, he can notify to the producer or the other threads that I consumed now. So the other consumer threads or the producer threads can access that shared resource. So this is what all it means is, and you understood this, I hope. If not, I can explain it again. So hope everyone understood this, right? How the producer thread and consumer thread are functioning.
Yes, Mark.
Yes, thanks. So now let's create two threads. and one thread will start executing the producer and the other thread should start executing the consumers. So for that, what I'll do is like I'll create two threads, and one thread will start executing the producer and the other thread starts executing the consumer. So let me create instance for this because I want to call the produce and consume method. So I'm creating instance for this particular class, new, and control V, and done. So we created instance for this. Now thread dot thread thread 1 is equal to new thread, right? So this is my thread declaration, and inside this I have my function here. So new runnable with instance, and the function for that is, I can even declare the function here. I doesn't really need to put add unimplemented methods. So this is another way of so instead of calling a new class over here inside this runnable inside this interface, I just implemented the method here itself. So I have created public void run, and I'm using this instance here, pcc dot produce is the method that we have inside that. So produce is the method inside this, and we need to make this as final. Add throws declaration, and then I need to implement a second thread which starts the consumer thread. Thread t2 is equal to new thread, and again insert this new runnable. So add unimplemented methods, and this is control D, and inside this we need to call the consumer surround with try catch. Now we have two threads. One thread is handling the producer and the one thread is handling the consumer. So this is my thread 1 and this is my thread 2. So this is handling consumer thread, and this is the producer thread. So I have two threads. Now let me start both the threads and let's see the output, how each other is communicating with each other and how effectively they are doing. So it's just a communication between the producer and consumer, right? So consumer will notify to the producer or the other consumer thread saying that my consumption is done. Now the other consumer or the other producer can access the same shared resource. So once this consumer thread notifies to the other users, the other user, the producer or the other consumer, can check into this particular shared resource or to the product, and they can start adding the products, or they start consuming the products. It depends on the thread, what thread that we have called. Okay, in this case let's see how it is happening. So we created two threads for the producer and consumer, and we have created instance, and now let me call both the threads. Let me start both the threads. So what I am doing now, I need to start this thread. 3.1 is the producer thread, and I need to start it. Control V dot start, and the other thread is T2. So this is my second thread. I am copying the name of this thread and I'm just starting it. Control V dot start. Okay, now everything is done. Let me start the execution of this particular thread. Run as Java application. So producer added, consumer consuming it. So now the producer added again two products, consumer consuming it. So the maximum capacity that the producer is able to add is 2, because we constrained the capacity to 2, right? So once the production is done, it is notified to the consumer is consuming it. So and then it is notified the product list is empty, so producer is adding it, so consumer is consuming it. Keeps on going. It's an infinite loop, because as I told, while loop is an infinite loop. So the producer keeps on adding the products, consumer will keep on consuming the products, meeting the conditions. Producer cannot add more than 2 products, and the consumer cannot consume if the product list is empty. So until unless we stop this threads communication, it will keep on going, and the transaction will keep on proceeding between the producer and the consumer. This is how an inter-thread communication can be established. If the producer don't say or didn't notify to the consumer, consumer will not buy the products, and there stops the threads execution. If the notifier didn't notify to the other consumer will not be able to consume this. Or it, when notifies something, it will release the shared resource so that other thread can access, can start communicating on this particular shared resource. Let's say, so you understood this, right? How this intercommunication is happening, and the producer now is able to keep on adding the products, and the consumer now able to keep on consuming the products which are there in the application. Is this clear to everyone?
Yes, sir.
So if you want to see the code once again, you can have an overlook here. You can have a look here. So this is just a thread initiation, and we called a method inside in this producer consumer class. So this is produce is one method and consume is one method. We call the produce method on one thread and consume method on the other thread. So this is all, and we started both the threads. Both threads started executing. So if you come here inside this produce method, and we are allowing only one thread to access this particular produce method at once, because we added synchronization. So here we have added an infinite loop, and we also have a product list. And if the product list dot size, the maximum capacity that we can add is 2. So if it is reaching the maximum capacity, this thread has to be in wait state. It cannot proceed further with the execution. So if it is not equal to capacity, producer should be able to add the products. So he is adding the products to the product list, and he is also notifying to the other threads saying, I'm releasing this particular shared resource or the product list. Now the other thread can start using that particular shared resource or the product list. So now the producer added the products and he released it, and now the other threads got the notification saying that there are some products in the product list. Now the consumers, this is the consumer method, and again it's an infinite loop, and inside the infinite loop we have a file loop saying, if the product list dot size is equal to 0, if there are no products in the product list, the consumer has to wait until the products are being added to the e-commerce application. So as he has to consume it, the producer has to add the product. So we are adding the products to the product list. The consumer has to consume the products. So we are removing the element from the product list. So in this product list we are removing one element saying like, we are removing one element in the list saying that the one item will be reduced from the product list. So here we have consumer consumed, and the consumer is releasing the thread and saying the releasing the lock so that other threads can consume this particular thing. Okay, this is how an intercommunication can be established between the threads. Hope everyone is clear with this. Hello.
Yes, sir.
Yes, sir.
Is everyone clear, or someone wants me to explain again?
It's clear, sir.
Okay, so this is all about threading. And now coming to the most important things in these particular sessions, that is data structures and algorithms. So data structure is nothing but organizing our data. So how we will organizing the data, and what are the different ways, and how we can organize the data in different ways. There comes different data structures. It can be list, hash table, or array, stack, vector, whatever it can be. The way how we are organizing the data varies from one data structure to another data structures. But the whole thing that we do, that we study in data structures, is how we will organize the data. is all that we will study in the data structures. Algorithms is something, the logic that we will develop to implement something. So let's say if you go to the machine learning, we have multiple algorithms that are being developed. It can be 2 lines of code or it can be 1,000 lines of code. It is designed to.
Mama, I want this. Want this. That's up. Huh?
So whatever it can be 2 lines of code or 1,000 lines of code. It is designed to achieve some particular task, and how effectively we will develop the algorithm and how scalable, how readable our algorithm is what that is important when coming to the algorithms. We have many algorithms for searching an element in an array or in a particular list or whatever it can be. For searching or sorting, we have many number of algorithms that have been developed. Each person has a different thinking capabilities, and he will be able to develop a different kind of algorithm to achieve a particular task. So the capability of each person is not unique, so that the way the person codes will also be unique. So the better thinking capability person will have the capability to write the best code, and the least capable person has the capability to write the worst code. So the decision making can be done means like which code is the better code and which code is the worst code, can be decided based on few factors, so one of the factors is readability and the other factor is scalability. So what is readability of the code? So let me put it in words. So a better code or better algorithm can be decided based on the readability and the scalability of the code. So readability is something, let's say you developed the code for something. You developed an algorithm, and now you're moving out from the organization, and new person joined to the organization, and he has to start working on the algorithm that you have developed. And now how fastly the new resource is able to adopt your algorithm uh, is called as readability. So readability can be achieved, I mean to say, you're simply writing something, and you're not, your code is just giving the right output, but you're not following any indentations, or you're not following any coding standards that have been provided or that have been set in the project, and you're not writing any comments on the functions that you have been developed. If you see any jar files that are being provided for different applications, it can be any automation tool like Selenium or whatever it can be. If you go to the functions which are there in that particular jar file, you will see the comments on each and every method that is being written over there, and that comments above that method will clearly says that what this particular method will do, and what arguments needs to be passed for this method, and how to use this method will be clearly mentioned over there, and the time that is, and the time at which it is developed, and the author who developed that. All these comments will be there on that particular method, whichever it is. It provides a clear idea to the user, saying that, so yeah, this function is developed for this particular purpose, and this is developed on this. So you can check for the latest versions based on the time it is developed, and you can also see the authors on it. And if you are not providing those comments, so the new person who is coming into the project has to go to the entire code, and he has to understand the entire lines which are being developed over there in this particular method, to understand the functionality of that method. So which is not a good case. So the user who is coming has to struggle a lot to understand that. And if you're not maintaining any coding standards or indentations, when the code is going big and big, so if the indentation is not there, it is very tough to understand where the loop is ending and where the loop is starting, and all these stuffs, all these difficulties will be there. So it is very important for a good code to maintain the readability of the code, so that the new user who is coming, or the users who is using your code has to be capable to easily grab that. That is what readability means is. So whenever you're writing a code, you need to follow the coding standards that are being set. For example, if you're declaring a constant, the name of the constant should be in capital letters. So you need to maintain the indentations. You need to follow the naming convention for everything. It can be camel case or whatever it can be. You need to follow the naming convention for methods, classes, variables, whatever it is. So, and for every method that that you're developing, it has to have some comments on top of it, and it should have author, and what is the argument that needs to be passed, what is the return type of that particular method, and what is the purpose of the method, and all this stuff has to be there on top of that particular method that you are developing, which is called as readability. And once it is done, it creates a good impression for the user, saying that this is the perfect coding, and he can easily understand what is constant, what is method, what is class, what is return type of that particular method. So that is what readability is, and you can easily understand it, you can easily adopt that as well once you are into the project. So what is scalability? Scalability is something that is very important to decide this is whether that is a better code or not. To explain this scalability, let me take an example here. New class, and let me call this as scalability, and let me create a main method here, and let me finish this. So this is my main method, and I'm asked to write a logic to find out an element in an array. If my element matches, I need to print something like element found. If it is not found, I need to print not found. That is all my logic. That's all the logic that I need to develop here. So let me write the code for that. Right. So I have something like string array here. String names array is equal to new string. Let me declare this as, let's say, 1000 elements. For I is equal to 0, for int I is equal to 0, I less than names array dot length, control C, control V dot length, I plus plus. So this is my iteration for the array loop. So assigning values loop, and checking values. So again I need to have the same array here, and I need to check if names array of I is equal to names array of I is equal to, let's say, X, and I'm trying to find the string inside this array, and then I need to print out compatible operations. I need to give us I here. So here I need to sys out apex font. So this is my code, and I also want to find the local date time dot now function home local date time before execution start time is equal to this one. So I'll copy the same thing at the end, control C, and at the end I'm taking the time of the execution, after execution time, after execution time. So I just want to calculate the time span for executing these steps inside this algorithm, or you can call this as a method for now. So to get the time, I need to have something called as duration time execution time. This is execution time is equal to duration dot mm, between. It's the method I forgot it. Duration. Duration dot between. Duration dot between. So from time to two time before execution time to after execution time. So can we expand this to 30 more minutes? Is that fine for everyone? Or do you want me to discuss this in the next session? Hello? Yeah, sure. Let's put this in the next. So Madhumati said she wants the next session. Sirisha is okay.
Yes, sir, we can do it.
So okay, you want me to do it in the next session, right?
Yes.
Right, then we will continue from here in the next session. So this is a completely new topic, and we know what is readability now, and we are discussing about scalability, and we will proceed with this in the next session. Meanwhile, I recommend every one of you to prepare a demo on the topics that we have discussed yesterday. And just a quick question, like anyone is ready with the demo to present the demo?
I didn't try the third one. Like if you're opening like so many browsers with two threads,
Okay.
I'm not getting that. But I know the differences for the thread class and the runnable interface.
Okay. Well, I hope we discussed about merge and rebase, right? The difference between merge.
Merge and rebase, yes. Yeah, I got to know about it, but I should know more about it, like clearly.
Okay. So what about connecting the GitHub with Eclipse?
I can show it. I don't know it's right or not.
No, you just, if you're able to proceed with push or pull, if you're able to do that, it's a
Yeah.
successful connection. That's all.
Yes, I tried it, sir. Yeah.
Okay. So let's
It
let's
was.
consolidate 2 to 3 demos, and let's put it on one day, because we are running out of time and we have many topics to cover. So mostly I'll allocate 30 minutes or sometime on some day to get this demos published to everyone. Or else if you have any session that is kept for demos or for your discussion, you can also discuss over there. So but for sure in next 2 sessions, I'll allocate some for time for these demos, and by then I request every one of you to get that ready, and request everyone. I, I'll I'll try to pick someone from the joinees list, and I'll ask someone to present the demo, and I request that person has to be ready with the demos by then, so that
Sir, I have a suggestion. Probably if next session anyway, like we start the class at 6:30. So from 6 to 6:30, we can have the demo.
yeah,
Like
sure.
whoever is there, they can show the demo. So when people are ready at 6:30, we can start the session.
Right, sure. Uh, yeah, we'll do that in the next session.
Thank you.
So yeah. So most probably, maybe as told, we will use the start 10 or 15 minutes for the demos, as we are waiting for the participants, more and more participants, right? So that time we can use it for the demos. So I request everyone of you to be ready with that, and you can also have your internal discussions to get the demos ready. And let's see that in the next session. And in the next session we are going to start with the algorithms, data structures, and the next 3 to 4 sessions will be on them, and then we will move to collection implementations and all these topics. The next 3 to 4 sessions are very important, and which shapes your coding skills into to other level. So when compared to the codings that you're writing, that you're using or developing right now, so these concepts, what readability, scalability, will change the perception of coding. So readability, said you like, you need to write the comments for each and every method that you're developing. You need to clearly mention what are the arguments, return types, what the function will do, and all this stuff. So that will be done by the readability. And scalability, we'll start discussing on it from tomorrow. So I'll wind off here, and let's meet in the next session. So thanks for everyone for joining, and most probably the next session will be day after tomorrow or tomorrow, or let me decide that, and let me and Shweta will communicate to you all. Thank you so much for joining,
Okay.
and you can wind off.
Okay, sir. Thank you.